Hello guys, this is a response to a question that one of our students asked. There are basically two questions. The first question is, why is formic acid HCOH more acidic than benzoic acid? This is a molecular formula for formic acid. Okay, so first have a look at this solution. Here is the structure for benzoic acid, here is the structure for formic acid. pK of benzoic acid is 4.21, pK of formic acid is 3.77, right? So we can say that formic acid is actually more acidic than benzoic acid. The reason is here the group you have is benzene ring that is connected to carbonyl carbon. A benzene ring is electron rich ring, right? So it's going to donate electrons to this electron deficient carbonyl carbon. Now this is electron deficient because of the presence of electronegative oxygen, we all know that. Okay, now because this benzene ring is donating the electron, it's going to increase the negative charge that will be formed on the carboxylate ion, right? And because of this reaction will be or this equilibrium will be less favorable as in the case with formic acid. Okay, so therefore the pK of a benzoic acid is going to be more than the pK of formic acid. Okay, now the second part or the second question is, why is ortho-nitrobenzoic acid much stronger than para or meta-nitrobenzoic acid? Now this is actually a very good question. Now here is explanation for that question. Now the pK of ortho-nitrobenzoic acid is 2.16, pK of para-nitrobenzoic acid is 3.41, whereas the pK of meta-nitrobenzoic acid is 3.47. Now we know the explanation for the pK of these two guys, right? The pK of para-nitrobenzoic acid is less than meta-nitrobenzoic acid. The reason is because the group at meta position has lesser effect than the group at para position, right? So NO2 group is an electron withdrawing group, and therefore it is going to stabilize the form negative charge, right? So equilibrium will be in a favorable direction, or you can say the pK or you can say that it is fairly easy to pull off this proton in para-nitrobenzoic acid than to pull off the proton in meta-nitrobenzoic acid. Okay, so para-nitrobenzoic acid is relatively more acidic than meta-nitrobenzoic acid. But the explanation, but the real question is, why is the pK of ortho-nitrobenzoic acid less, right? Or why is ortho-nitrobenzoic acid more acidic than each of these guys? Okay, if you look at this is actually a discrepancy, because this is actually exactly opposite of that what we taught about the pK of phenols or substituted phenols. Okay, if you look at the substituted pK of substituted phenol, what you see is that orthonitrophenol has a pK of 7.17, paranitrophenol has a pK of 7.15. So this is slightly fairly equal. Ortho substituent is slightly higher or less acidic, whereas meta is actually more, right? So it is less acidic basically than either of these two guys. Okay, for these two guys the pK, you can say that, right, the pK of paranitrophenol is less than metanitrophenol, because, well, the nitro group at meta or at para position has much electron withdrawing effect than at meta position, and therefore the pK drops. Okay, the pK of orthonitrophenol is slightly higher than that of paranitrophenol, and the reason is because this proton here on the OH group of phenol actually forms a hydrogen bond with the oxygen. Okay, and therefore it is slightly difficult to pull off the proton here. So the dissociation constant of this this phenolic group is going to be slightly higher than this phenolic group. Okay, therefore the pK is slightly higher by a very slight margin, but it is higher than paranitrophenol. Okay, you cannot apply the same logic to our nitrobenzoic acid. Okay, because if that is the case, if you say that this OH group is going to form a hydrogen bond with the O of nitro group, then the pKa of nitrobenzoic acid, orthonitrobenzoic acid, should be higher than para-nitrobenzoic acid, right? But that is not the case. Here the OH group does not form a hydrogen bond with the oxygen of nitro group. The reason is because of the steric hindrance. Now if you were to form a hydrogen bond, you are essentially going to form a 7-membered cyclic ring. So the hydrogen would be somewhere here. You're going to form a hydrogen bond with the hydrogen and then the hydrogen bond. Okay, so the hydrogen, if you were to form a hydrogen bond, you will form a 7-membered ring. In phenol example, we were forming actually a 6-membered ring, which was favorable, and therefore the pK of orthonitrophenol was higher than paranitrophenol, right? Whereas in this case that is not the case. So why is the pKa of orthonitrobenzoic acid actually lower than that of paranitrobenzoic acid? Well, the reason is because in this example the benzoic group is pushed out of plane by the nitro group, okay, and that is the reason why it basically prevents the benzoic acid group or the the acidic group of the nitro of this compound. It pushes it out of the plane, and therefore it is favorable if this proton is removed. Then it is basically brought back into the plane. Now this entire structure would be in plane. Okay, so it is favorable to remove the proton and bring the carboxyl group in the plane, so that the resonance stabilization can come into play and stabilize this negative charge. Okay, this is the reason why this orthonitrobenzoic acid actually has lower pKa. You can say that the reactant is actually more, or this compound is more destabilized because of the nitro group pushing the carboxyl group out of the plane. Okay, as soon as you remove the proton, the situation is now much favorable. There is less steric hindrance, and entire molecule is in plane, and the entire negative charge is stabilized by the resonance on the entire molecule. Okay, so this is the reason why this compound has a lower pKa than paranitrobenzoic acid. I hope you guys understood this. If there is any question, please mail me.